Today's class is about trigonometric equations, and the objective of this section is to solve basic trigonometric equations. So let's begin with a simple example. In example 1, we're going to solve the equation sine of t equals negative square root of 3 over 2. And we need to think of the following. Which angle on the interval 0 to pi, or which angles, in case it's more than one, have a sine value of negative square root of 3 over 2? To help us this answer, we can use a unit circle and do the following. With each angle, there is associated another pair, and the value of the sine is associated always with a y-coordinate. So in here, what we need to do, if we have a unit circle with us, is to look for those y-coordinates whose value is negative square root of 3 over 2. Here we have one of those. For the angle 4 pi thirds, the other pair that is associated with it has a y-coordinate negative square root of 3 over 2. And also, because there is another one, the angle 5 pi thirds has a y-coordinate associated with it of negative square root of 3 over 2. Therefore, the values of the angle that we're looking for, it is 4 pi over 3 and or 5 pi over 3. So if we evaluate these values into the function, and we're expecting to get a value, and the value that we're going to get is going to be negative square root of 3 over 2. So sine of 4 pi over 3, it will be negative square root of 3 over 2, or it will replace the t by 5 pi over 3. The value of the sine of 5 pi over 3 must be also negative square root of 3 over 2. Okay, let's make a second example. And once again, we're going to solve in the interval from 0 to 2 pi without including that 2 pi. And in this case, we're going to solve the equation cosine of t equals negative 1/2. And again, we can ask the same question. Which angle or angles on the interval 0 to 2 pi have a cosine value negative 1/2? And one more time, guys, we can look at a unit circle. And in this case, we're going to ask the following. Or we can look for the following. Look for those other pairs whose y-coordinate is negative 1/2 on the unit circle. And here we have one. And the angle that is associated with this point is the angle 2 pi thirds or 120 degrees. And there is another one. And it is the angle 4 pi thirds whose x-coordinate associated with it in the other pair, it is negative 1/2. Therefore, the angles 2 pi thirds or 4 pi thirds will be a solution of this equation. And that will be the solutions of the example 2. Let's make another example. In this case, we're going to try to do the following. We're going to begin by isolating trigonometric expressions. So let's see what is the equation given. In this case, we need to solve the trigonometric equation 5 cosine of x equals 3 cosine of x plus the square root of 3. And one more time, we're going to solve it on the interval from 0 to 2 pi. And here we have the solution. We can begin by collecting on one side the like terms or the like expressions. And you notice we have a cosine expression on the left and a cosine expression on the right. So we can put them together on one side. And 5 cosine of x minus 3 cosine of x, it will give us 2 cosine of x. And the equation becomes 2 cosine of x equals square root of 3. We need to isolate the cosine of x is being multiplied by 2. So we can get rid of this by dividing. So the cosine of x becomes equals square root of 3 over 2. And then what we need to do is to find the measure of the angle. So x will be equals, every time that we need to find the angle, we can do this. X will be equals to the inverse cosine of the square root of 3 over 2. And one more time, we need to find out for which angle the value of this, for which angle the cosine of that angle, it will be equals the square root of 3 over 2. And one more time, we can use a unit circle to help us to answer this question. And the procedure is like the previous ones. Let's see, we're looking for an x-coordinate in the unit circle whose value is the square root of 3 over 2. So here we have 1, this other pair, square root of 3 over 2, comma 1/2. In that other pair, the x-coordinate is square root of 3 over 2. And the angle that's we're looking for, it is pi over 6 or 30 degrees. But we're interested on the measure of the angle in radians, so it would be pi over 3. So the value of the x will be pi over 3. Is the only one? Let's see. Here we have another one, another angle. You can notice also for the angle 11 pi over 6, the value associated with it, the x-coordinate associated with it is square root of 3 over 2. So the angle 11 pi over 6 also will lead us to an answer. Therefore, we have two solutions. X will be equals to pi over 6 or x equals to 11 pi over 6 on the interval from 0 to 2 pi. And if you replace these values into the equation, you must get the same value on both sides. Let's make another example. Example 4. And in this case, we're going to do a different technique. This case, they're going to give us an equation, a trigonometric equation with a quadratic expression. And the technique to solve this kind of equations is going to be taking the square root of each side. So let's see the example. Solve 3 tangent square of theta minus 4 equals -3. And one more time, we're going to solve it on the interval from 0 to 2 pi. Let's see the solution. We need to begin by isolating the expression with the tangent. So the -4, we can add it on both sides. And the equation becomes 3 tangent square of theta equals 1. Then we need to divide both sides by 3. And the quadratic equation involving tangent becomes tangent square of theta equals 1 over 3. But we're not interested for tangent square. What we need is a tangent of theta. So we're going to do in the next step, we're going to find the square root of both sides. So the tangent of theta becomes equals plus minus the square root of 1 over 3. Taking the square root of 1, it will be 1 over the square root of 3. It's not exact, so we leave it like square root of 3. But we need to rationalize because we cannot leave radicals in the denominator. So really easy to rationalize. We multiply the top and the bottom by square root of 3. And when we simplify, this expression becomes plus minus square root of 3 over 3. And in the next step, we're going to get two equations. Why? Because we have the tangent of theta equals to plus minus square root of 3 over 3. So one equation will be tangent of theta equals square root of 3 over 3. Or the other equation, tangent of theta equals negative square root of 3 over 3. So we're going to solve both equations. And both equations are going to lead us to one or two answers. Let's see. Again, we're going to need a unit circle. And in this case, it is different from the other ones. We're not going to find directly a value x or a value y related with the tangent of theta, not directly. We need to think of the following, for which, for example, we need to remember the following. The tangent of theta, by definition, is opposite over adjacent, or if we define it like other pair, it will be y over x. And basically, guys, what we need to do is to find out, by looking carefully at the other pairs, which other pair will lead us to, when we simplify, because it's y over x, to the value square root of 3 over 3. So let's see the following. I notice that the other pair that I just enclosing here, square root of 3 over 2 and 1/2, it's connected, but it has to do with the values that I have in tangent of theta equals square root of 3 over 3. So also, I notice that this other one, negative square root of 3 over 2 and negative 1/2, is also involved in the value of the square root of 3 and 3. So in here, what we need to do, guys, we know that the tangent, it is positive in the first one and in the third quadrant. So for definition, tangent of theta is equals y over x. And like I said at the beginning, if you see, if it is y over x, and I use these values that I proposed before, and if I use in the one in the first quadrant, for example, the value of the y coordinate, or the one enclosed in the first quadrant, is the y value is, the y coordinate is 1/2, and the x coordinate is square root of 3 over 2, and tangent of theta becomes equals to y over x equals 1/2 over square root of 3 over 2. And if I simplify this expression after using E operation and getting rid of a radical in the denominator, it becomes square root of 3 over 3. That is exactly what I have originally. Therefore, the angle that is associated with this one is the angle 30 degrees in the first quadrant and the angle 7/6 in the second quadrant. Remember, since tangent of theta equals square root of 3 over 3, it means that it's positive. The tangent is positive in the first and in the third quadrant. Therefore, the angles that we're looking for in this case were pi over 6 or theta equals 7 pi over 6. using a similar procedure, since my second equation is tangent of theta equals negative square root of 3 over 3, I can see that I can define tangent of theta equals to negative y over x because it's negative, the tangent in this case. And I can look for all the pairs with the coordinates similar to the ones that I use, but taking care that one of them is negative. And one that rises in here, it is the other pair, negative square root of 3 over 2 and 1/2. And the other one that arises in here, it is the other pair that is circling here, square root of 3 over 2, comma, negative 1/2. So if I use with any of these, actually, any of these, tangent of theta, it will be cos negative y over x. It will be negative. I use, for example, let me see, if I use the one in the fourth quadrant, negative 1/2 over square root of 3 over 2. And if I simplify this, I will get an expression that is negative square root of 3 over 3. And I can do exactly the same if you think of the other pair that is in the second quadrant, that the x coordinate is negative and the y coordinate is positive. So negative divided by positive is negative. It will be also leading us to tangent of theta equals negative square root of 3 over 3. So if you need to find the angle, theta will be equals to the inverse tangent of negative square root of 3 over 3. And which angles are those? Okay, the angles connected with this other pairs circled in green are theta equals 5 pi over 6 or theta equals 11 pi over 6. Let's see another example. Also, another technique that we can use for solving trigonometric equations is factoring. So let's say an example, how factoring can be applied. Actually, we're gonna do two examples. Find all the solutions for each equation on the interval from 0 through 360 degrees. We're gonna do one with degrees. So we're gonna solve the equation 2 sine of x cosine of x equals square root of 3 sine of x. And if you notice, in this case, in both sides, we have in common the expression sine of x. So let me make one side equal 0. So it would be 2 sine of x cosine of x minus square root of 3 sine of x equals 0. We can factor the GCF, the greatest common factor, that is sine of x, and the expression becomes, after factoring sine of x times 2 cosine of x minus square root of 3, and we make this equal 0. So now that I have this, what I can do next is to set each of the factors equal 0. So sine of x becomes equal 0, or the 2 cosine of x minus square root of 3 equals 0. So we can solve the first equation. If sine of x equals 0, it means that x equals to the inverse sine of 0. And once again, we can use a unit circle and we can ask the following question. For which angle the sine of theta is equal 0? So we need to look on the unit circle for a y coordinate 0. So we have this one, and we notice that the y coordinate of this other pair is 0, and the angle associated with it, it is 180 degrees or pi. And this is the, let me see, this is the, also we have another one. This is the other angle that, or the other pair whose y coordinate is 0. And we notice that in this case, the angle associated with this other pair, it is 0 radians, or 0 degrees in this case, because we're gonna give the answer in degrees, because the question is at the beginning to give the answers in degrees. So therefore, the values of the x equals 0 degrees or x equals 180 degrees. And let's solve the other one. Leaving alone the 2 cosine of x, this becomes equals to 2 cosine of x equals square root of 3. Then we need to leave alone cosine of x, so the cosine of x is multiplied by 2, so the 2 passes divided on the other side. And now we have the cosine of x equals square root of 3 over 2. And one more time. In the unit circle, remember the cosine is associated with the x. So we need to find on the unit circle the x coordinates whose value is square root of 3 over 2 and associated with an angle. So let's see. We're gonna have the angle pi over 6 is associated with another pair whose x coordinate is square root of 3 over 2. Therefore, one of the values is pi over 6, one of the angles, but there is not the other one. If you keep on looking around the unit circle, you know that the cosine of theta is also positive in the fourth quadrant. So we have the angle 11 pi over 6 has also an x-coordinate that is positive square root of 3 over 2. Therefore, the angles, or since I said at the beginning, the angles must be given in degrees. So if I said 11 pi over 6, I need to check, my answer must be in degrees. So 11 pi over 6 is 330 degrees. Therefore, my answer, my final answer for this second equation would be x equals to 30 degrees or x equals 330 degrees. If you notice, we have more than two solutions. We have two solutions given by the equation sine of x equals 0, and the other one given by the equation 2 cosine of x minus square root of 3 equals 0. Therefore, putting all together the solutions would be four solutions: 0, 180 degrees, 30 degrees, 330 degrees. Let's make another example where we need to factor. So we're going to find all the solutions of the equation 2 sine square of x plus sine of x minus 1 equals 0 on the interval from 0 to 2 pi. In this case, we're going to give the answer in terms of pi. So if you notice, in this case, we cannot use GCF. It's not possible to use GCF. It's nothing in common between the three terms in the equation. The equation is already equals to 0. And I notice that this equation looks like a typical quadratic equation. It looks like if I said, forgetting about the sine square of x and the sine of x, it looks like I have to, let's say, u squared plus u minus 1. So we're going to proceed to solve this equation by factoring, but we're going to use, in this case, the technique that is called trial and error or guessing method. So let's see. A possible factors of 2 sine square of x, it would be 2 sine of x and sine of x. And for negative 1, it would be negative 1 and 1. And the way that we have learned to do this, to check if these are the factors, it would be to multiply across 2 sine of x times 1 and sine of x times negative 1. We add them, the products, to sine of x minus sine of x. And in this case, the answer equals to sine of x. This is exactly the expression in the middle. So it means that the trial and error method that we use at this moment works. So the factors, it would be 2 sine of x minus 1 and sine of x plus 1. So we put them together into an equation in factor form. And this expression would be 2 sine of x minus 1 times sine of x plus 1. And this would be equal 0. Then, by using the zero product property, I can make each of the factors equals 0. So it becomes 2 sine of x minus 1 equals 0, or sine of x plus 1 equals 0. And we solve the equation at the left. Sine of x becomes equals 1/2, and x will be equals to the inverse sine of 1/2. Again, we use our unit circle. We look at the unit circle for the, since we're looking for the inverse sine, for a sine, we look for the y coordinate whose value is 1/2. And here we have this order pair. This is the y coordinate is 1/2, and the angle associated with this is 30 degrees, or in radians pi over 6. Since our answer must be in radians, I will take pi over 6. But I know that also the sign is positive in the second quadrant, and I notice that in the second quadrant, the order pair negative square 3 over 2, comma 1/2, the y coordinate is 1/2, it is positive, and the angle, that's actually what I'm looking for associated with it, is pi over 6 in radians. Therefore, the solutions for the first equation are the values pi over 6 or 5 pi over 6. Now let's solve the second one. Let us leave the sine of x alone. Sine of x equals -1. X would be equals the inverse sine of -1. And in this case, we're gonna look for a y coordinate that is -1 in the unit circle. Can you find one that is -1? One y coordinate that is -1 in this order pairs? Actually, I have this one. I notice the y coordinate at this point that I have in here, 0, -1 is -1, the y coordinate. And what I'm interested is in the angle in radians, and I notice that the angle that is associated with this order pair, 0, -1, 83 pi halves. And actually is the only order pair or the only angle whose y coordinate is -1. Therefore, the solution is 3 pi halves. Putting all together, we have three solutions: pi 6, 5/6, or 3/2. And finally, let's use the identities that we have learned in the previous sections. We can use trigonometric identities combined with algebraic techniques to solve some trigonometric equations. So let's see an example. Solve by rewriting using a single trigonometric function. And the example that we're gonna solve, it is the following. Find all the solutions of sine squared of x minus sine of x plus 1 equals cosine squared of x on the interval from 0 to 2 pi. And you notice in here we have something raised to the second power. We have sine squared to the second power, cosine to the second power, and we have a sine. So in here, we cannot use factoring since the beginning at least, maybe once we start solving it, because I have expressions in terms of sine and cosine. So maybe it would be helpful to use one of the Pythagorean identities. But let's see. Let's begin making one side equals 0 as we did before when we solve by factoring. And we move the cosine of x to the left side, and the expression becomes sine squared of x minus sine of x plus 1 minus cosine squared of x. And here comes the recommendation that it seems that it will work. I know that the Pythagorean identity, one of them says that the sine squared of x plus the cosine squared of x equals 1. And if we make a transformation out of that trigonometric equation or trigonometric identity, Pythagorean identity, we can get the following. Cosine squared of x equals 1 minus sine squared of x. So we can replace into the equation sine squared of x minus sine of x plus 1 minus cosine squared of x. We can replace cosine squared of x for 1 minus sine squared of x. And that's exactly what we have done in here. So the equation becomes sine squared of x minus sine of x plus 1 minus, we open parentheses to replace the expression cosine squared of x, the equivalent expression, and that expression is 1 minus sine squared of x. So in the next step, we can get rid of the parentheses by using distributive property. If we simplify, this becomes sine squared of x minus sine of x plus 1 minus 1. Negative times negative will be plus sine squared of x equals 0. Then we can combine the terms. We can actually cancel 1 and negative 1. That becomes 0. They cancel. Then we notice that we have two expressions raised to the second power. So sine squared of x plus sine squared of x becomes 2 sine squared of x minus sine of x equals 0. And here again, we can use the previous technique that we use, factoring. I notice the sine of x is in common, so we can take it like a GCF, and the expression on the left becomes sine of x times 2 sine of x minus 1 equals 0. So we factored sine of x. And then we have two factors, sine of x equals 0, and the other one, sine of x equals 1/2. So again, once we get at this point that the sine expressions are completely alone, we can use our unit circle. And beginning with the equation on the left, we can start searching in the unit circle for a y-coordinate 0. And we notice the one other pair that contains is the one that is circled in here that contains a y-coordinate 0 is 1, 0, the other pair. And the angle associated with this is the angle 0 radians. But also there is this other pair, negative 1, 0, whose y-coordinate is 0. And the angle, that's what I am actually looking for. It is pi, or 180 degrees, but I need it in radians, so it's pi. Therefore, the solution for this equation would be x equals 0 or pi. Now let's solve the second equation, that is sine of x equals 1/2. And I notice that the y-coordinate of another pair that is 1/2 is this one that I circle. Is the other pair is square root of 3 over 2, 1/2. And the angle, that's what I am actually looking for. It is pi over 6 or 30 degrees, but I need it in radians. But is there any other pair whose y-coordinate is 1/2? And where we can find it? Actually, we can find it in the second quadrant, because in the second quadrant, the sign is positive. And the other pair, it would be this one. It is the order pair negative square root of 3 over 2, comma 1/2. So the y coordinate is 1/2. But what I need actually is the angle that is associated with this. And the angle is 5 pi over 6. Therefore, the values of the x are pi over 6 or 5 pi over 6. And putting together the solutions, we have 4 solutions. X equals 0, or x equals pi, or x equals pi over 6, or x equals 5 pi over 6. So we have 4 values that satisfies the original equation.